No introduction needed. You already know what it is. You get me? What are you telling me? Alright, again with this pure two situation. Alright, come on. Expand this then. Question 1A, yeah? Question 1A is saying select the statement. It's just question one. It's not even question 1A. State the statement that there is negation of all multiples of three are even. Yeah. So if he's saying all multiples of three are even, yeah, that means that the opposite of what he's saying is that at least one multiple of three is not even. Yeah. So it's odd. Yeah. So that's number B. You get it? So hence B is the correct answer. Yeah. Calm. Easy. Yeah. Let's move on to question two. Alright. Cool. Question two. Yeah. Question two is saying write down the negation of each statement. So the first one is that all rich men are happy. Yeah. So what's the opposite of that? Obviously, at least one. At least one rich brother ain't happy. Yeah. So that's the situation there. Let's look at part B. What's part B saying? Part B is saying there's no prime numbers between 10 mil and 11 mil. So therefore, what we're gonna say is the opposite of that. There is a prime number. Yeah. There is at least one prime number between 10 million and 8 and 11 mil. Come. C. If P and Q are prime numbers, then PQ plus 1 is a prime number. So if P and Q are prime numbers, then PQ plus 1 is a prime number, yeah? So therefore, we're going to say the opposite of that, yeah? We're going to say that if P and Q are prime numbers, yeah, then there exists a number, PQ plus 1, that is not a prime number, yeah? So you're just saying the opposite of what my man's saying, yeah? Come on. Part D is saying all numbers of the form 2 to the power of n plus 1 minus 1, sorry, are either prime numbers or multiples of 3, yeah? So he's saying they're either prime numbers or they're multiples of 3, yeah? So we got to say that there's a number in the form of 2m minus 1 that is either not a prime number or not a multiple of 3, yeah? So also try to use this language here. Don't just say 2m minus 1 is not a prime or whatever, yeah? Say there is a number in the form or there exists a number like that, yeah? You're trying to get the full marks, you get me? Come on, and then E is saying at least one of the above four statements is true. So if he's saying at least one of the above four statements is true, I can't say all of the above four statements is true because that would include what he's saying. At least one is true. So we can't say that as the opposite. The opposite to what he's saying would be that none of the above statements are true. And don't try to skip stuff out, yeah. Don't try to skip out like the four statements and just write the statements above, yeah. With proof here, it's important. Just write the full thing and see what happens in it. You get me? Because you never know. You never know how the examiner's trying to be. So yeah, it's not worth risking those marks, man, over something small like that. Alright, come on. Question 3A, yeah? So question 3A is saying if n squared is odd, yeah, then n is odd, yeah? And it's saying that write down the negation of that statement, yeah? So I can say that if n squared, then there's number n that's even, that's not odd, yeah? So that's the opposite of what he's saying. And then part B, if you look at part B, yeah, it's saying prove the original statement by contradiction, yeah? So listen, fam, to write an even number, it's in the form of 2n. But since we already used it, we're using n here, let's use 2k instead of 2n, yeah? So n is equal to 2k, yeah? If I square that, that's going to give man n squared, yeah? So n squared is equal to what, fam? It's equal to 2k squared, yeah? 2k squared is just going to be 4k squared, yeah? Because you expand the 2 here, 2 to the power of 2 is 4, and then k to the power of 2 is k squared, yeah? Calm. And that's the same if I take 2 outside. That's the same as 2 open bracket 2k squared, yeah? So what did we achieve from that exactly? You're probably asking. Well, that means, yeah, that n squared is what, fam? N squared is an even number, you get it? Because we've got 2 times something. An even number is always 2 times something, yeah? So therefore, because even number can be divided by 2 or can be halved here. So therefore, what can man say here? I can say that hence n squared is even. So since n squared is even when we put when we put an even number inside, that means that for n squared to be odd, n also has to be odd, bro. You get it? Oh, question 4. Question 4a, yeah. Question 4a is saying prove the following statements by contradiction. There is no greatest even integer. Yeah. Okay, so that's number A. So what we can say here is there is a greatest even integer, yeah? So say the opposite. Calm. If no one's gonna say that there is a greatest even integer, yeah, then we can call it 2n. Let's just call it 2n, yeah, because 2n is an even number, yeah? Calm, fam. And as you know, yeah, even plus even becomes even, yeah? And so what I can say is that a bigger number than 2n, yeah, would be 2n plus 2. And this is another even number, yeah, because it's got 2n, which is even, as we established in the first line, and we got plus 2, and we know 2 is an even number, so that means that the product is even, yeah? So I can say that this is an even integer, yeah? Calm, fam. So now what do you do, yeah? And it's also bigger than 2n. Can't get. So because 2n is plus 2 is bigger than 2n and it's also an even integer, that means that there is no biggest even integer. You get. Calm. Now let's do part B. Part B is saying if n cubed is even, yeah, then n is even. Calm. So we're gonna say there's a number for. It's always the last line that you need to tweak here. So it says that n cubed is even, then n is even. We're gonna say n cubed is even, but n is odd, yeah? Calm. So what's the form for odd number, yeah? Form for odd number is 2n plus 1, but again we're already using n, so let's just use 2k plus 1 instead, yeah? Calm, fam. And then now we just need to cube that n to get n cubed, yeah? So let's cube that. Let's square that first, yeah? So n squared is equal to, I am gonna write n squared in it. Let me just square n, yeah? So 2k plus 1 squared. You want to use a squared plus 2ab plus b squared, yeah? So that's a, that's b. So a squared is going to be 4k squared plus 2ab, that's going to be 4k. 2 times 2k is 4k times 1 is 4k. And then plus a 1 squared, yeah, which is b 1. Yeah, calm. That's b squared, yeah. And then times that again by 2k plus 1, yeah, to obviously get n cubed. And you're going to find, yeah, that when you do that, obviously to expand this, you should do 2k times each one and then do 1 times each one and combine it. I'm going to combine it already, yeah? So that's going to be 8k cubed, yeah? Plus 12k squared plus 6k plus 1. Calm, fam. Let me delete that too. Calm. Plus 1, yeah? Alright, save. So now what do we do, yeah? So that's the situation there. And what I can do, yeah, is I can actually take this little part here, yeah? And you see that 1 over there, I can leave that one as 1's on the right, yeah? And then I can just take 2 out of this whole part here. So if I take 2 out of that whole part there, it becomes 4k cubed, yeah? Plus 6k squared plus 3k, yeah? Plus 1, yeah? And so obviously this works. If I times the 2 back in, it will give me the top line, yeah? So what can I say now then? I can say that this is obviously n cubed. And what have we discovered here? We have discovered that n cubed is actually, it's actually odd, yeah? This is a form of an odd number. You've got 2 times something plus 1, yeah? It's the same as like 2k plus 1, yeah? So this is odd, isn't it? So hence n cubed is odd. Yeah. So if we want n cubed to be even, yeah, then n has to be even, yeah, because we tried it when n is odd and it gave us an odd number, yeah. So there you go. Come, see. If PQ is even, that at least one of P and Q is even, yeah. So what I'm gonna write is that if PQ is even, then P and Q are not. Or there you can say they are odd, yeah. That's a more legit way of saying it, but I don't really care for. So yeah, P. Let's call that again 2k plus 1 since we're saying that P and Q are odd numbers here. So so that's 2k plus 1. And Q, because we already used up K, I don't really want to use N, we can use M, yeah? So 2M plus 1, yeah? Confirm. So therefore, let's add them, let's times them together now. We need to find PQ and prove that that is going to be even, yeah? So let's prove that then. P times Q is equal to what, fam? It's equal to 2k plus 1, yeah? Open bracket 2M plus 1. And obviously, if we expand that 2k times 2m, whatever is going to become 4km plus 2k plus 2m plus 1, yeah? Calm. And now if I take out 2 here, again, how we did the other thing earlier, so put 1 on the side and take out 2, yeah? So 2, open bracket, 2km, yeah? Plus k plus m plus 1, yeah? So again, this is in the form of an odd number, yeah? As you see, yeah? This is the same as like 2k plus 1 form, yeah? So because this is a form of an odd number, you got 2 times something plus 1, yeah? What I can say is that PQ is also odd. So therefore, PQ is even, and either P or Q is even, yeah? Alright, calm. That's part C done, yeah? Let's do part D, yeah? Part D is saying what, fam? It's saying if P plus Q is odd, then at least one of P or Q is odd, so just do the same shit, fam. So if P plus Q, then neither P or Q is, or you can just say that P or Q is even then. So therefore, yeah, what man can say is that P is equal to, so in this time we need a form of an even number, yeah, which is normally 2 times something, yeah, so 2 times k, yeah, 2k, yeah, P equals 2k, and Q is equal to 2m, yeah, confirm. Now what can I do, yeah, I can say that P plus Q, that's what I need to find now, and I need to prove that it's even or whatever, yeah, and if it's not even, it's going to be odd or whatever, yeah. Alright, calm. So P plus Q, that's going to be 2k plus 2m, and guess what, you might think, yeah, what do we achieve from that here, what can we actually do from that, yeah? Why we got a 2 now here, 2 there, yeah. What I can do from that, yeah, is I can take out 2, I can factorize that, yeah. And it just becomes 2 times k plus m, yeah. So this is what p plus q is, yeah. And this is actually an even form again. If you look at it, it's 2 times something, yeah, which makes it even, yeah. So therefore what I can say is that p plus q is even, yeah. Then at least one of p or q is odd, yeah. Alright, come on. Question 5a. Prove that if a, b is an irrational number, then at least one of a or b is an irrational number. Come. Yeah, so if AB is irrational, yeah, so I'm gonna say the opposite. Yeah, I'm gonna say if AB is irrational, then neither A or B is irrational. Yeah, so I'm trying to say that either A or B is actually they're both rational. Yeah, calm. So let's prove that then. Let's see the situation. So how do you represent rational number? A rational number is a number that can be represented as a fraction where the two integers are not they can't be broken down any simpler. Yeah, so like let's say 1/3, for example. Yeah, so here's C over D. this is a rational number because it can't be broken down. And let's say B is equal to E over F, yeah? So A, B, C, D, E, F, yeah? Calm. Yeah, and you also got to say this, yeah? It's important, yeah? Write this down, yeah? Say where where C and D are integers, yeah, that have no common factors, yeah? So they can't be broken down further, and they're both full numbers, they're not decimals or anything, yeah? And same thing here, yeah? Okay, calm. So now, yeah, let's find AB, yeah, let's times A by B, yeah. So AB is gonna be equal to what, fam? It's gonna be equal to CE over DF, yeah. Just times the top with the top, bottom by bottom, yeah. Calm. We got CE over DF, yeah. And so hence I can say that hence, yeah, AB is also rational, fam, because CE is just gonna become one number, and DF is gonna become one number, and they're all different numbers, yeah. So you got no commonality between them. So that means that AB is also rational, fam. I could write this as M over Q, fam. You get me? So therefore, what can I say is that hence AB is also rational, and if AB is also rational, that means that if I want it to be irrational, yeah, that means that A or B has to be irrational, yeah. So there you go. Alright, come on. Part B says prove that if A plus B is an irrational number, then at least one of AB is a irrational number. So here we're doing A plus B instead of A times B, yeah. So but it's the same principle, yeah. So maybe try this one on your ones here, see if you can do that. B. I mean, no one is watching this video to do the ones anyway. They're doing it for like acceleration. So anyway, so doing the same thing here, we're saying instead of if A plus B is irrational, yeah, then neither A or B is irrational. So they're both rational numbers, yeah. And so again, fam, let's say that A is equal to C over D, and let's say again that B is equal to E over F, yeah. And again, you need to write the whole integer thing. I'm gonna write it again for you lot, yeah, because I'm not like your sneaky teachers that ain't writing shit, lazy. You know what I'm saying? I'm gonna write it for you, man. So hence C and D are integers with no common factor. And I'm right here for you, man, as well. They shouldn't say hence, so I don't know why I put hence. Man just likes to use that word, innit? If you haven't noticed by now. You ain't clocked that. Alright, calm, yeah. So what are you saying then? So that's the situation there. So let's just do A plus B now, yeah. So A plus B is equal to what, fam? A plus B is equal to C over D plus E over F. Now listen, if you don't know how to do this, you might actually be finished, yeah. It's adding fractions, yeah. So times the bottom, yeah. But it's calm actually, yeah. You'll learn. If you don't know how to do it, you learn. It's calm. Times it together, yeah, you get DF, and then times F up there, you get CF plus DE, and then you cross multiply. So D times by E, F times by C, and you put a plus and whatever sign this is here in the middle. It's the same if you're subtracting, yeah. Alright, calm. And that's what you get, yeah. You get this situation there. And deep here, this is just the integer plus the integer, which is just another integer. And then we're dividing by integer times integer. So it's just integer over integer. So effectively, this is also rational, yeah? So therefore, you see, hence just gets the job done in it. Like, therefore, yeah, is a bit too, you know what I'm saying? Yeah? But hence is just nice and sleek, you get me? So that's why I like using it. Alright, calm. Makes you sound like you're of certain, you know what I'm saying? Certain people as well. Alright, calm. C, again. What's he saying? So he's saying a student makes the following statement, yeah? He's making some big statements. He's saying that if A plus B is a rational number, then at least one of A or B is a rational number. Show by means of counting example that this statement is not true. Well, listen, fam, he's chatting worse because if I have a as a number minus a root, and I have b as a root, and I add them together, the root's gonna cancel in it, so you're gonna get a rational number. So, quick example of that is a is equal to 2 minus root 2, and b is equal to, you can really put any rational number here though, it doesn't matter. Irrational, yeah? And root 2, yeah? So if I add these together, it's just gonna give man 2, yeah? Which is obviously rational, yeah? So he's chatting shit. Alright, go on. Question 6. Question 6 here. What's question 6 saying? Saying use proof by contradiction to show that there exists no integers a or b for which that is a situation. Okay, calm. So I'm gonna say the opposite, yeah? I'm gonna say that there is. You know what, fam? I'll make it a capital as well. There is. You gotta put that as a couple. You get me? You can't let this intimidate you. You get me? You can't let maths intimidate you. G. That's how they get to you. That's how you get to your mind. Yeah, you need to treat them like it's nothing. You get me? Alright, calm. So what should I do now? Let me divide both sides by 7. The reason I'm dividing by 7 is because 21 and 14 will both be divisible by 7. So hence I can divide by 7, and it will become 3a plus 2b is equal to 1 over 7. Yeah. Now you're probably thinking, okay, cool, but what does that actually achieve? Yeah. Well, what did we say? Yeah. That plus that must equal actual integer. Yeah. In. So this must have to equal integer. But deep it. When I make it equal to 1 over 7, yeah, the sum of the two integers here must also be an integer. This is an integer. This is an integer. So they must make an integer, but they're not making an integer. They're making 1 over 7, fam. You see that? So right. Yeah, but 1 over 7 is not an integer, it's a decimal number, yeah? It's not a whole number, yeah? So hence what I can say is that that means that either A or B, one of those is also not an integer, yeah? And to be said that there exists an integer where that can be the case. So hence there is no integer where that can be the case. You have to use a decimal for that to be the case, yeah? So hence I can say that 3A plus B, if they're both integers, can never equal 1 over 7. That doesn't make any sense. And so I can say that hence the come on, safe. Question 7A. Prove by contradiction that if n squared is multiple of 3, n is a multiple of 3. So what I'm going to say is that there's a number. Listen, you're getting used to this here. There's a number for n in which n squared is a multiple of 3, but n is not a multiple of 3. Yeah? Come. Safe here. So what I can say now is that I need to actually prove this here. So hence I can say that n is equal that in the hint box they tell you what to use. They tell you to use 3k plus 1 and 3k plus 2. They're just using two consecutive multiples of 3 here. So 3k would be a multiple of 3, but 3k plus 1 is not a multiple of 3. So I'm saying that n is not a multiple of 3, so we're doing 3k plus 1. And so that means that n squared here is just 3k plus 1 squared here. Again, use a squared plus b squared plus 2ab. So 9k squared plus 6k plus 1. That's equal to n squared. And now you already know the drill by now. You're trying to show that this is I'm trying to show that's not a multiple of 3 to contradict it. So hence, take out the 3. So take out the 3 from just that part there. That becomes 3k squared plus 2k. And leave the 1 outside by itself here. And so again here, you've got a non-multiple of 3 here. You've got 3 times something that's a multiple of 3. And you're adding 1. So it can't be a multiple of 3 here. Because you have the 1 remainder if you divide by 3 here. So hence, n squared is not a multiple of 3. And it also hints at using n equals 3k plus 2. So you can use that as well. You should use that as well to show the next multiple, because essentially everything else after that, yeah, 3k plus 3 will be a multiple of 3, and then everything else after that is just a factor, like it's just a multiple of either 3k plus 1 and 3k plus 2. Does that make sense? That's why you got to show it for both of these things, yeah? Does that make sense? So yeah, so n squared, and that's why you don't need to show any other ones. So 3k plus 2 squared. You can also do 3k minus 1 and 3k minus 2 if you want. Alright, calm, instead of these, instead of plus 2 and plus 1. Alright, cool. So square that, yeah, you get same situation here. Squared plus 12k plus 4. And now what you're going to do here is the same situation, but break down the 4 into a 3 and a 1. So 9k squared plus 12k plus 3 plus 1. And then take out the 3 again, yeah? So same situation. It's always the same situation. So take out the 3, get 3k squared plus 4k plus 1, and then plus 1 there. 3 obviously divided by 1, 3 is 1, yeah? So that's why you got that situation. Alright, come. And hence, again, n squared. So if n squared is a multiple of 3, yeah, then n also has to be a multiple of 3, yeah? Come. Let's do part B. Part B to question 7 here. It's saying, prove by contradiction that root 3 is an irrational number, yeah? Hence proves you're going to need to use part A at some point. But let's do that then, yeah? So I'm going to say that root 3 is a rational number. Yeah, so if I'm saying that root 3 is a rational number, yeah, what does that implement? What does that actually mean here? What does that imply here? That implies that root 3 is going to be equal to a over b, yeah? Again, that's how you do this. That's what a rational number is. It's a fraction that can be represented like that, yeah? Where I can say where a and b are integers with no common factors. Confirm. So let's look at this situation now, yeah? So let's look at that, yeah? So we've got root 3 is equal to a plus b. Obviously, first thing you need to do, yeah, this is anything. Proving anything is a rational number, you always follow the same kind of format, yeah? So do that and then square both sides. So 3 is equal to a squared over b squared, yeah? And then times b squared up there, you get 3b squared is equal to a squared, yeah? Calm. Now that you've got this situation, yeah, that means that a squared must be a multiple of 3, yeah? Because you got 3 times the number. So therefore, a squared is a multiple of 3. And if a squared is a multiple of 3, therefore a is also a multiple of 3. Yeah, because we said earlier, in the earlier thing, if n squared is a multiple of 3, then n is a multiple of 3. That's what we said in part A. So from part A, you know that. Yeah? So hence I can say that I can write a as just like 3c. You'll see what I'm doing that in a minute, yeah? Calm. So let's do a squared now. Let's write a squared is equal to 3c squared, which is equal to 9c squared. Yeah, the reason I brought c into this, by the way, just to show that a is a multiple of 3, yeah? You'll see how it all comes together in a minute, yeah? Full circle, yeah? So, and we said that a squared is equal to 9, is equal to, what did we say? A squared is equal to 3b squared, yeah? So if a squared is equal to 3b squared, that means that, and a squared is also equal to 9c squared, that means that 9c squared is equal to 3b squared, yeah? And then divide by 3, you get 3c squared is equal to b squared. And now square root, you don't need to square root both sides. This proves that b squared is also a multiple of 3. Do you see that? Yeah, because you got my man there, you got the 3 there. Yeah, so therefore, yeah, it's also a multiple of 3. And so if it's also a multiple of 3, then it's a bit of a peak situation, isn't it? You get me? That means that B is also a multiple of 3 then. And that goes against what we were saying originally, that there's no common factor between A and B, that they're two integers with no common factor. But A is a multiple of 3 and B is a multiple of 3. So therefore they can both be divided by 3. And you might be thinking, cool, but then you divide it by 3 and now it's irrational, right? But no, that's the whole principle is that A and B are the simplest integer. So you can keep going round and round in circles, you get me? So that's how you prove something is an irrational number. Yeah. Um that's the whole point is that you can't rationalize it. It keeps going down, you keep and there's always a common factor. There's no two things on top of each other that are not related. Come that can't be broken down. Question 8. Question 8 said use proof by contradiction to prove that the statement that there is no integer solutions to the equation x squared minus y squared is equal to 2, yeah? Alright, calm. So I say that there's no integer solution, yeah? So he's saying, what is he saying? That there is no, sorry, yeah? He's saying there is no integer solution, yeah? So we need to say there is an, yeah, there is one, yeah? Alright, calm. That was a little correction on my part, yeah? My bad, my bad. Alright, calm. Yeah, let's do part 8 then, yeah? So part 8 is saying what? It's saying that, yeah? So let's then try to solve it, yeah? So we can say that x squared, yeah, minus y squared is equal to 2. So let's find the solution. So x and y should be numbers, they should be integers, yeah? Alright, go on. So let's solve this. This is just a difference of two squares here. So this is x minus y and x plus y is equal to 2, yeah? Come on. That's the difference of two squares on the left here. You got something squared minus something squared here. Alright, come on. And now, to make 2, yeah, you can have a certain number of combinations. You can either have, this is two brackets timesing each other, by the way. So you can either have 2 times 1, you can have 1 times 2, you could have minus 2 times minus 1, or you can have minus 1 times minus 2. Obviously, you can have other things, but we're assuming that these are both integers, isn't it? So these are the only things you can have. Alright, come on. So let's look at the first one then. So let's make x minus y equal to 2 and make x plus y equal to 1. And so if we solve for x here, so just add these two equations together, the y's will cancel, you get 2x equal to 3. So that means that x is equal to 3 over 2, so divide by 2. And then that means that y is equal to what? Minus 1. And then just put x back in to find y. So 3 over 2 minus y is equal to 2. Bring y there, delete 2 there. So 3 over 2 minus 2, yeah, and you'll get a minus a half here. So therefore, or whatever, yeah. Alright, cool, minus a half, yeah. So therefore, these are not integers, yeah. These are two decimal numbers here. So that means that it doesn't work for the first line here. Let's try the second line. So let's make 1 x minus y. And let's make the other thing, x plus y equal to 2, yeah? And obviously, you get the same result. We're going to get it flipped this time, though. So you don't even need to calculate this one. It's just going to be the same thing flipped. So here's going to be what x equal to minus 1 over 2. Even actually. Y is cancelling again. So it's the same shit. So x is equal to 3 over 2 again. Yeah, and y is equal to minus 1 over 2 again. Yeah. Alright, come on. Alright, see, let's use this to see the further one then, yeah? So let's make minus 2 equal to x minus y, yeah? So x minus y is equal to minus 2. And then x plus y is equal to minus 1, yeah? And then again, if you solve for x here, solve for x, you'll get just add the two equations together. The y's will cancel. X is equal to minus 3 over 2. And y is equal to minus 1 over 2, I believe. It's not like that. It might be 1 over 2. I don't know. I don't really care. It is 1 over 2, so yeah. Well, and then let's do the other side. So again, same thing. So x minus y is equal to minus 1 this time. And x plus y is equal to minus 2. And now just add them together again. Y is going to cancel. Minus 1 minus 3. X equal to 2x equal to minus 3. So therefore x is equal to minus 3 over 2. And y is equal to, it should be the same, no? Whatever. I've got minus 1 over 2 written down, but it's obviously 1 over 2. I don't really care. It doesn't matter. The whole point is that it's irrational, isn't it? It doesn't matter if it's correct units or whatever. Yeah? Just put it in, try it. So try it somewhere. Add 1 there, plus 1. No, it will be negative. Come on, or something. Anyway, yeah, well, it's ridiculous. Come on. So hence, yeah, from what we saw there, none of the solutions here are integers here, so I can say that hence there is no, Yeah, there's no intersolutions to that, yeah? Integer solutions. Alright, calm. Let's look at question 9 then, yeah? Question 9 is saying what? Question 9 is saying prove by contradiction that the cube root of 2 is irrational here. So I'm gonna say that the cube root of 2 is rational here. So I'm gonna say that this is irrational. Yeah, that's a rational assumption, yeah? Alright, calm. So now I can say that again, same thing, bro. Say the same thing, say that root 2 over 3, if it's irrational, that means that it can be represented as a over b, yeah? And I can say that a and b are both integers, yeah? Alright, calm. And if they're both integers with no common factors, yeah, then what can I say? I can say the same situation. You just need to yeah, it's just cube everything. So a cubed. So cube both sides, and you get a cubed is equal to two or a cubed over b cubed is equal to 2, yeah, and then times b cubed up here, you get a cubed is equal to 2b cubed, yeah. Alright, come on. So what can I say here? I can say that because a cubed is even number, it's equal to 2 times the number, yeah. That means that a cubed is even, and obviously if a cubed is even, that means that a is even, yeah. So and so therefore a is also an even number, yeah? And so I can call that even number, I can call a, same way how we did last time with the multiple 3, or whatever it was, or even I can say 2n, yeah, or 2c or whatever, yeah? And hence I can replace a cubed with 2n cubed, yeah, is equal to 2b cubed. And hence that becomes 8n cubed is equal to 2b cubed. You got the hang of this now, divide by 2, so it becomes 4n cubed is equal to b cubed. And so therefore I can say that b cubed is also even because you've got 4 times something, yeah, and 4 can be broken down to 2 times something, yeah. So therefore they so hence yeah, because they're both a and b are both even, that means that a and b have a both have a common factor of 2, yeah. So therefore two cube root of 2, yeah, is irrational, yeah. Come, let's look at 10a then, yeah. Question 10a. So we got it's saying here, this is some student here, some joke man, yeah. He's done this question and it's saying what has he done wrong here? Well, if you look at what that happened here, yeah, he said that a minus b over b, yeah, and he's trying to prove that they're all positive here. But a minus b over b could actually be negative. It doesn't prove anything, right? It might be a negative number if you put certain numbers in there. So hence, that's a mistake. Is that a can be negative? So to not allow this room for this negative thing, because of course A and B are both positive, but that doesn't mean anything. I can put 2 minus 3 over 3 or whatever. That's still not gonna, yeah, and that's gonna be negative or whatever, right? So therefore, yeah, that's what I'm trying to say is that or whatever, yeah. So that's what I'm trying to say. You can't have minuses here. So the real way to do this, which is in part B, yeah, is first of all make the assumption. So say that there is at least so there is a least here. So a least natural number. Yes, there is a least rational. So saying there's a smallest rational number. And what we've got to say is that we're gonna call that smallest rational number a over b, yeah? And hence m is gonna be a over 2b. Yeah? And if you think about it, if I times the bottom here by 2, it's gonna make this number m smaller because you're dividing by a bigger number. and there's no room to say that anything can become negative here because A and B are both positive here. So hence, this is how you do it properly. And so I can say that n is therefore bigger than m. So there's a smaller number than n, which is m. And so hence there is no smallest here. Oh, and that's the end.